Hey guys, Kodak Harness here. Welcome back to my workbench. So today I've got one of these things. Turned up in the mail the other day. It's a preheating station. So you throw your PCBs on top, preheat them up to a reasonable temperature, and then you can use your hot air gun just to blow the surface mount or desolder stuff or whatever. So picked one of these up, relatively cheap on Amazon, and I thought I'd just do a quick tear down to make sure it's safe. Sorry about the camera refocusing, bit of a glare here, sorry, but yeah, if we do that. So yeah, first observations, those sides are nice and smooth, but front and back are like razors, so I'm going to probably run a file or something across edges there, but yeah, so fairly easy. It's got set and up and down, so presumably you can set the temperature and yeah, then we'll run it through. But anyway, let's just whip this bottom off. And let's see what it's like inside. One of these I saw getting torn down a while back. This is the newer generation. The previous generation had like a transformer mounted under here. This one doesn't seem to have any screws, so I'm not sure about the if there's a transformer in this one. Let's have a look. And 1, 2, 3, ta-da! Ooh, nothing in here. What we got? Some fairly good feeling heat-proof cables, some heat shrink, some abrasion resistant stuff. Oh, how's the mains connections coming in looking? Okay, they look like they're fairly reasonable. Off on switch used. Control panel there. So far it doesn't look like it's... So on the other one of these I saw, sorry about the bit of the exposure, a bit overexposed. Let's see if I can just kill that. What happens? Kill my lights. Yeah, we might have run with that. The other one of these I saw had the transformer mounted here, and the heating elements ran on, it was 24 volts, 12 or 24 volts. This one, look, we've got a, must be a triac or something switching here, or sidac, but something like that. But yeah, let's just whip this off. Let's see. I need one off. No, I need a. Let's see if that fits. There's 4 screws holding the feet on. And then 4 screws, one of which holds the ground. I'll have to check the ground in a minute. That goes directly through to the mains. Nice. Relatively simple so far. 8 screws to take it to bits. And let's see what we've got. So we've got a nice bit of shielding there to stop the wires getting cut, and to be fair, those holes are smooth. They've been powder coated, so I don't have to worry about the wire getting cut too much. No, we don't want to. Here it is. 4 more screws. Let's see what I've got. So those, oh, there. So we've got little pillars here which stand off from the base to the heating plate, and they're mounted solid. Let's see what we've got. Lift that up. We got the heating tubes, bit just slid in there. What we got? Okay, so they're in a probably aluminium casing. And slide it in and out, so it'll be fairly easy to replace if necessary. Yeah. But how are you doing on the old bit? And then each of those is then screwed to the plate. That looks fairly solid. Yeah, overall it's not too bad. They're bolted solidly in. That must be the temperature probe there, which is a bit offset, but you'd hope that with the heating here, the heat would spread evenly in both directions. That being the middle means we're going to have a hot point here and here. That should get up to temperature rather quickly, you'd hope. Right, well, there's nothing much to see here. Two heating elements running at 240 volts rather than the 24 volts I've seen before, so hopefully this is well earthed. So the earthing's on the back in here through the screw. So it's earthed through to the screw through onto this. Into these. Right, so the earth is actually mounting, getting screwed directly into a steel aluminium post, which is screwed into the top plate, which also looks aluminium. So that's reasonable. Okay. Well, let's put it back together. And let's see. Make sure we put the... It's wanting to slide forwards. Just basically, these tubes keep sliding. The heating elements keep sliding forwards. I don't really like that. You want to keep them as central as possible. How to stop them moving? Well, I think temporarily I've just got some Captain tape here. Will that hold up to that temperature? I don't know. Hang on a minute. Here a search. So I'll Google Captain tape max temp. Says 260. Well, that says here it can sometimes use up to 400. I'm not planning on going higher than 250 on this, really. Let's just put a little bit on. Can't hurt. Nah, better part of me saying no. Let's just keep an eye on this as we put it in. Okay, that one's sticking out. That one's not. Let's put it in. Okay. They're pretty much right now. Okay. Slide that anti-friction pad back in. No, not anti-friction, anti-fray. Let's throw this on. And we'll test the earth connectivity to make sure we're happy that everything is well and truly earthed. I mean, this is a powder coated case, so chance of getting a shock through the powder coat, I should hope, would be fairly low. Don't know what the conductivity of powder coating is, but given the fact that the earth here connects straight through to the actual steel plate, you'd hope that you've got fairly good earthing. Nope. Not middle. Yeah. Well, let's get the opposite corner done. Yep. That's tight. That's tight. The anti-fray is Yep, screw. One more screw. Actually, sorry, not screw. So, to widen it, circuit board. Have a look at it. There's nothing. Don't know what that will come through. Here we go. Oh. Here, look at it. Looks like it's got a microprocessor, driver controller. That looks like the switching unit there with the heatsink on it. Bit of a terminal block that everything seems to be nicely locked into. Yeah, I'm not going to pull that circuit board to bits. Maybe for another day, but let's put this on. Then let's test the earthing. Make sure we're happy with everything is nicely earthed. Let's plug it on and see. Plug it in and see how fast it gets up to temp. Hopefully this thing should. Tell me what it actually said on the box, not the wattages. What's it say on it? 60 hertz. It says it's got a 600 watt. With a 6 amp fuse in it. That's interesting because at 240 volts at 6 amp, that's, if my maths is right, 1200 watt. Let's see what the old fuse says it is. Come on. It's got a spare fuse, which is nice. Need my glass out for this one. I got my glasses on, but let's just get the old headset on. What's this say? 250 volt. Fast blow 6 amp fuse. Okay. Fuse matches the spec, so I'll take that as a good thing. Yeah, spare fuse, it's nice. It's got the old safety feature that you have to have the plug out before you can play. So here, you've got this little catch on the back of this. Look, won't be able to just, have a look here. There's a little catch that comes out. So when you slide it in, catch sticks up at the back here, so you can't actually pull the fuse out with the plug-in. Nice. Right, so more importantly, is that earthed? It's time to get the old trusty multimeter. Positive to earth. No connection to anything else, that's good. Turn the power off. Below. Yep. Let's get the casing. Nope. How about those? Right. Let's see. There's no earth to anything other. No. So nothing's earthed. Well, it's working. The main thing is that is earthed. And the wire is connected directly to this. So yeah, everything else is powder coating. There's no, can't detect any resistance. So that powder coating must be reasonable thickness because it's not conducting. Unless powder coating doesn't conduct. I don't know, never looked into it. Right. So that's the unit. so far I'm quite happy. The security, not security, the safety seems reasonable. So let's get the old thermometer out. Just temperature. Let's see. People see that? Yes, that looks good. K-type. Oh, they're positive, negative. Positive, negative. Yep, there we go. Plug that in. Unplug those. Right. Untangle this. What's a comma? So what are we at now? 23 degrees in the shed today. That's not bad. Oh. Don't take yourself up. Right. So let's just make sure that is touching down and tape that down. Where did I put my Captain tape? There. Make sure it makes a decent thermal connection to the top of the board. Was it right? So let's put that right there. So if we remember, heating elements ran that way, and the thermal couple was here. So, and I'm planning on putting the boards here in the middle. So let's just see how well that gets temperature. Power coming in the back. Okay, let's turn on. That's set to... Set, press set button. Okay, press set. Let's set to 100 degrees. And go. Right. So that's saying it's currently at 24 degrees. Let's get a stopwatch going. Timer. Nope. Stopwatch. Go. So that's telling me it's at 30 degrees. That's not too bad. So 33, 34, okay, 35. So that's telling me it's now 40 degrees. It's not bad. About a degree below. I'll take that. So degree every couple of seconds. That's not too bad at all. We're at 50. Still lagging about. So this is about a degree below what this thinks it is. Yeah, being warm. How are we going now? We're at 60. Interesting. That is now reading higher than this. It was lagging, now it's in front. Because this is saying 68, 69, 70. So it's reading a degree low now. It was a degree high, it's now a degree low. So that's a minute 20 to get to, let's just call it 80. Okay, 82, 83. Right, we'll spin this up until we hit 100. And that's 100. So that's at 100 degrees. It's stopped, it's paused. So how much higher is this going to climb? So it's 5 degrees above where it should be. It's slowing down. Oh, there we go. It slowed down. So it's about what, two. Right. I'll let that spin on for another couple of minutes. Let's see where we get up to. Oh, well, that's 9 minutes at least. So that's 9 minutes. Yeah, so if you've been watching this, it's kind of dropped, went up to 108. So it went up to 108, then dropped back down to about 94, then back up to 96. And so it's reading, let's say 94, 96, let's say it's hovering around about 95. So it's reading about 5 degrees low, which is manageable. So let's just crank it right up. Let's see, what did I say? Let's just see what 250 gets us. So that. No, that's about, at 100 it's 5 degrees low. At 250 it's about 12 degrees low, 10 degrees low. I'll tell you, that's not too bad. Right, we'll stop that. So just turn this off and let it cool down. Let's just check. Oh, okay, so that is scalding hot. So yeah, that blue thing, but the white, warm, top's warm, but the sides are cold. And the legs that are running down between the two are quite hot. So yeah, if this was running, I mean, I did read in the instruction manual, it says this will be designed to run for 8 hours at a time. That's going to get quite hot. The front is, so the top of there is warm, but I don't know how much of that's radiated or transmitted. You know, it's in radiated heat from the top down, or whether it's transmitted through those screws and legs and stuff. But yeah, I think that's going to work quite nicely. Let's just get that off. So yeah, that is my let's just unplug that. Don't even know how to pronounce this one. I'm sorry, guys, but this is my 246C preheating station. It seems to be, yeah. So this part here, that part's hot. That part there is really hot. That's warm. That's top's warm, bottom's cold. So yeah, going to be interesting to see how well this works. I will definitely be putting it through its paces at some stage when I start getting some surface mount kits which I've got on order. But yeah, hope you found that enjoyable. Like and subscribe. I'll just get rid of this bit of Captain tape while it's nice. It's all sticky at 250, which is quite good. Right. So yeah, like and subscribe, guys. Follow along. Hopefully you'll see this in action at some stage soon. How's the camera? Okay, camera itself isn't too bad. It's still quite warm here. That's quite hot, but that's a bit of radiant heat up here. But yeah, like and subscribe, guys. I'm trying to keep these electronics videos to once a week. If you have any suggestions or anything you'd like me to have a look at, drop us any comments. And as always, I shall catch you next time. And I'll see you later. Bye.